Hey y'all, it's Sarah, and today we're going to go over another limits concept. This one is about solving limits using the conjugate. So today we're just going to be doing two examples that'll hopefully show y'all like how to work through these types of problems. So this first problem, if we just go ahead and substitute in 4, right, because it's a rational function, and by the direct substitution property, we should try that first. Here's what we get. Okay, so now we have 2 minus 2 over 0, so 0 over 0. That's not possible, right? That's something called an indeterminate form. And in the future, you will learn a way to solve limits that result in indeterminate forms using derivatives, but we haven't learned derivatives yet, so we need another way. And so what we're going to do instead is we are going to take this limit, and we are going to look at the part that has the square root in it. So here that's in the numerator. And we are going to multiply the whole fraction by the conjugate over itself, right? So we're multiplying by 1, so it's okay. But the conjugate here, because we have square root of x minus 2, the conjugate is square root of x plus 2. So we multiply by that over itself. And so what we're going to get here is, so because on top, this turns out to be just the difference of two squares, right? And so we can simplify this down to just x minus 4 in the numerator. And then on bottom, we have x minus 4 times square root of x plus 2. All right, cool. So these x minus 4s can just cancel out. And so now we have the limit as x approaches 4 of 1 over the square root of x plus 2. So now let's do substitution. All right, so 1 over the square root of 4 plus 2, that's 1 over 2 plus 2, which is just 1/4. So that's our first example. It's a pretty simple one, but as you can see, this method is going to work for these types of rational functions with a square root that result in this type of indeterminate form of 0 over 0. We're going to try a slightly more complicated example next. So for this one, again, if we plug in -2 here, we're clearly going to get 0 over 0. You can work that out if you'd like to, but that is what we get. So we're going to multiply it by the conjugate. And remember, what's under the square root stays the same. The only sign that changes is the one between the thing under the square root and the other term. So here, actually, I'm going to need a new line for this. What we're going to get is x plus 2 times the square root of x squared plus 5 plus 3. And the thing that didn't originally have a square root, so here it's the numerator, when we multiply the conjugate times that, we don't want to actually multiply it out or FOIL it out. We just want to leave it how it is because we're going to be able to simplify later. And so again, we have a difference of two squares when we multiply the denominator. And so what we're going to end up with on bottom is going to be x squared plus 5 minus 9, which that just simplifies down to x squared minus 4. All right, so now let's take x squared minus 4 and let's factor it out. So it's a difference of two squares, and so we can factor it into x plus 2 times x minus 2, and then these cancel. So now we have the limit as x approaches -2 of the square root of x squared plus 5 plus 3 over x minus 2. All right, let's try and plug in -2 now. So just by direct substitution, and this is the part where we stop writing the limit, right? We stop writing this, and because we're actually plugging something in, it's not a limit anymore. So we have negative 2 squared plus 5 under square root plus 3 over negative 2 minus 2. So this becomes the square root of 9 plus 3 over negative 4. That's going to become 3 plus 3, so 6 over negative 4, and then we can factor out a 2 to get negative 3 halves. So again, our steps here, we multiply, we find that this rational function leads to 0 over 0 by direct substitution, so we multiply by the conjugate, and then we just simplify until we can factor something out, and that allows us to get to a form where we can actually do direct substitution to get an answer. All right, if you enjoyed this video, please like and subscribe.